Hey guys, Josh from Solution Based. Still working on thermostats. We're going to talk about a heat pump thermostat. This gets into one that gets difficult for some homeowners. There's a lot going on in amount of conductors and functionality that it takes to get a heat pump to operate. So I'm going to lay that out for you so that at least you can see where you're at when you start going with this. And you know, I'm doing this in front of the whiteboard because trying to show the backlight of the thermostat on a video, I can get the video to be somewhat good, but it's not perfect. So I'm showing you this. I am gonna do a video with a couple of thermostats and try to get the best picture I can with me actually operating the thermostat. But this way you can really see what's going on clearly. I'll do one of mounting one on the wall. I'll get those pieces settled for you. But functionality, selection, wires, all that stuff, kind of classroom time is your best bet with that. So lots of wires with a heat pump. We're going to deal with this as if it's a single stage heat pump. If it's more than one stage, you're just going to have extra wires on Y2. So just know that. So the difference, one of the biggest differences is we're going to have a defrost board that we have to work with the functionality as well, and that adds a layer of complication. So typically we have 8 wires coming into the thermostat, and we have 5 wires if it's single stage coming into the defrost board. Okay, so here's what's going to happen. Okay, you're going to have Y1. Okay, Y1 is your condenser wire. Okay, same as in air conditioning, it just tells the condenser that it's time to turn on, and it tells it it's time to turn on in both heating and cooling. So the Y wire doesn't know or care whether you have a call for heating or cooling. All it knows is it's time to turn the condenser on. Okay, where the rubber meets the road with a heat pump is right here. That's your reversing valve. Okay, inside of heat pumps there is a valve that allows it to switch from heating to cooling. It quite literally reverses the system and allows it to do both functions. Okay, so your O or your B or OB is your reversing valve terminal. Okay, a little bit of complication there. There are some systems that tried to be too cute and decided they were going to switch the way their reversing valve works compared to everybody else's. The two most common ones are Rudd and Rheem. Basically, they're the same company. And what the difference is this. When a heat pump is sitting there, sitting on the ground, just doing nothing, okay, it is in heating mode. So if you just if you don't power the reversing valve at all, and you just give it Y1, it's going to come on in heating mode. When you power the reversing valve, it's going to come on in cooling mode. Rheem and Rudd are the exact opposite of that, and your thermostat, when you program it, is going to ask you heating power for reversing valve or cooling power for reversing valve. There'll be a question right in there, and basically you're going to know that anything other than a Rheem and a Rudd, you're going to set it to power for cooling, because when it gives it 24 volts at the reversing valve, you'll be in cooling mode. So that's one of the extra wrinkles with a heat pump. Then you have emergency and auxiliary heating. Emergency and auxiliary heating can go to a couple different things. Most commonly, it's going to go to a electric heat strip that's inside the air handler. Sometimes, like in mine, it goes to a boiler coil, and it has a fan control on there for emergency heating. And that is going to come on anytime that the temperature outside can't satisfy, or excuse me, the temperature outside is so low that the heat pump curve can't satisfy the needs inside the house. That's usually based on amount of run time versus temperature. So if it runs for whatever, half an hour, and it doesn't start, or an hour, and it doesn't start to come up in temperature, then it's going to fall back to emergency heating, turn that electric strip on or boiler on, and then get that system over the hump until either the outside temperatures rise to a degree where the heat pump curve can then fill the capacity inside the house, or a call is no longer needed, one of the two. So in emergency and aux, it's going to ask you if you want, most thermostats are going to ask you if you want them both powered at the same time. Typically, you're just going to say yes. There are things that you can hook up to this system that you would want them to operate independently. If you have a system like that, you're probably looking at needing your technician to come out and do that, because that's even another layer of complication. So this emergency heat will operate on its own. It's an automatic switchover. So when it doesn't have enough capacity, it's going to be based on what the thermostat's programmed to do. It's going to switch it into an emergency heat without any interface from you. It also gives you the option to push it into emergency heat. That can be necessary for a couple things. One, it's taking too long and you happen to be in the space and it's blowing cold air on you and you're like, that's uncomfortable, and it's because it's too cold outside and the thermostat hasn't caught up yet, or whatever the case may be, and you can push it into emergency. The other one is there's a problem with the heat pump. If the heat pump outdoor goes down, you can push it into permanent emergency heat mode and run on your electric backup completely until you have a service technician come out and figure out what's going on with the outdoor and get that repaired. It's also with the heating on the thermostat, you're going to be coming from W2, okay? You're not going to connect to this. Do not connect a heat pump to W1. I can't tell you how many times, even technicians I have, that have tied into W1 and they forgot, and they are used to doing furnace. They tie into W1, and then I get a call back because we have to put that wire onto W2. So heat pumps are always wired into this W2 for primary heating. So that W2 is going to go down to your air handler that has your terminal blocks in it. So some of them have terminal blocks, some of them just have a bunch of wires sitting inside of the air handler. Either one, it doesn't really matter how that goes. The rest of the wires in here are doing the same stuff that they normally are doing. Your R wire is waiting for power, your common wire is common, G is fan, Y2 is going to be for 2 stages of cooling. All this stuff is the same. Here's something that I do want you to know. In your outdoor defrost, you're going to have all these wires landing inside of this air handler down here. So you're going to have a bunch of wires going on if you look in there. So R is power. It's the same R that's here. They're going to come to the air handler, and that's going to provide power for both of these systems, okay? So R here and R here, the same exact power source. That's what's going on. They're both providing power. W in, okay? W in is actually going to be tied to your W2 wire in your outdoor. That is when you're calling for regular heat pump heating. W2 here gets energized. W in or W1 is on the defrost board. That tells the outdoor that there is a call for heating. You're also going to have 24 volts on O, and you're going to have 24 volts on Y. So all of that is going to be going on at the same time, okay? In a regular call for heating, all of that gets fired up, okay? So that's how that's going to work on a regular call for heating. Here's what goes on. One, I already explained to you the emergency heating, how that when you have too cold of temperatures outside or some disruption to the system, it will then default to running your backup system, whatever that may be, okay? The other thing that's going to go on is this W out right here, this guy, okay? And that W out allows the defrost board to actually come back to the air handler and turn on the emergency source of heating. Well, why does it need to do that? Heat pumps do something called go into defrost mode, and I covered this in the heat pump outdoor video. But when the heat pump goes into defrost mode, what's happening is the heat pump generates enough cold that any moisture in the air actually clings to the coil outside, and it starts to build up ice on it. So there's logic in this defrost board that says every so often, it's timed usually, we need to run in air conditioning mode with the fan turned off, and what that does is it makes that coil get hot like it normally would in air conditioning mode, and then it melts off all that ice, hence it's called a defrost mode, and then releases some water vapor and gets the system back to a steady state. Well, during that process, which can take anywhere from 5 to 10 minutes, if this is blowing during that process, it's going to be blowing cold air all over the inhabitants, and that's not comfortable for anybody. And you can actually, on really cold days, there's more defrost cycles, they're more common, so what can happen is you can really end up losing some temperature and not being able to catch back up because you have that break in the system running. So what the defrost board does then is it energizes W out and sends it down here to the air handler and turns on your emergency backup strip while all of the defrost action is going on. And what that does is it keeps you from getting cold air blowing all over you, and keeps the temperature in the room from cascading down while that defrost action is going on. So you actually have to give the outdoor the ability to turn on your emergency source of heating, be it boiler or electric, so that during those defrost cycles you don't end up with a room that's 67 instead of 70, and then not being able to catch up because it's so chilly outside. So that's some of the differences with heat pumps and the way their thermostats work. Again, what I want you guys to do is I want you to open this guy up. You're not going to see, when you go to do a thermostat swap out, all of this. I want you to understand what all you have going on to just some small degree, so you understand how much more is going on here, and it'll help you decide whether you want to touch the thing in the first place. But if you do, I want you to do the same thing I always tell you. Do your research, make sure you have a compatible thermostat. Pull the face off the wall, take a picture of the way the wires are landed already. As we've said multiple times, the colors that are inside here don't really mean anything. They're a convenience matter. What matters is where those wires are landed on this base plate. That's what's giving it functionality. You're also going to have some questions, more of them, with a heat pump that are, when you actually put the face on there, when you program it, that are going to be a little more detailed. It's going to ask you things like how many cycles per hour. Cycles per hour, put it up to the max. Cycles per hour is it's foolishness. It will limit the amount of times that your heat pump can run in any given hour. And if you forget and set it on 3 cycles per hour and it's freezing out and it's satisfying often, or you have a drafty house where it has to cycle a lot, it'll then lock the system out for a half an hour, and the temperatures will plummet in there. So there are some questions that a heat pump thermostat is going to ask you that you're going to have to be prepared to answer. You're going to have to answer how many stages that are in it. You're going to have to answer, is this going to energize on cooling or heating, this reversing valve? That's your OB. Okay, you're going to have to be able to answer that. Some heat pumps have a need for a sensor wire because they're hybrids, and they have a boiler backup, and they actually have to lock out the thermostat at a certain temperature. If you get into that, you should be pretty advanced to be able to do that, because you're going to have to lock out your condenser at a certain temperature and force your backup system to come on, or you're going to create problems inside the system. So some heat pumps do require a sensor. If you open your system up and you see wires are on your sensor terminals and you have a sensor sitting outside, okay, then you should start asking some questions about what type of system you have. If you have a dual fuel or a hybrid heat pump system, you really need that sensor, and you're also going to need to know how to program it. The good news for you is that if you really want to try one, if it's one of these, make sure your HVAC technician knows you're going to try it, okay? Some techs and some companies really don't favor that, and they're going to give you a hard time. I really don't care if you want to try and put your thermostat on, and if you try and fail, I'm going to run out and help you, okay? The other thing is that you can get the manufacturer on the phone and their tech support and get them to walk you through. The wires, you should be able to get the wires back where they went, like I've told you, okay? But the functionality, the programming, they can really help walk you through how to properly set it up. If you say, hey, I have a hybrid heat pump system and I have this and I have that, they can walk you through, okay, now we're going to set out how to lock out your outdoor condenser. They're going to walk you through that, and they're going to be able to help you. And then, when you get into one this complicated, or any one thermostat swap out this is, I suggest maybe you do this early enough in the day. Don't do this at 3:30, okay? When Honeywell's closing, your HVAC contractor's closing, and everybody's going home. Don't do this 3:30 on a Friday or Saturday afternoon, when then it becomes an emergency service call. Do this as early as you can on a weekday if you can. It's just going to save you, an emergency service call over this would sting. So that's your heat pump single stage, and again, 2 stage, it's just going to have a Y2 wire, but that's a pretty basic heat pump. Anything beyond this, you might want to have your HVAC contractor do it. And if you're going to have a lockout on your sensor because you have dual fuel, you may also want to really make sure you understand it first, maybe put that call into tech support first, or have your HVAC contractor do it. Thanks, guys.